welcome. This is Graphical User Interfaces with Windows Forms, and this is going to be part 1. So let's talk a little bit, before I get into it, about what graphical user interfaces are. A graphical user interface is exactly what it sounds like. It's a means by which a user can interface with the application that you're trying to use or write. And this allows them to have inputs to it. So for instance, a graphical user interface would be something like your smartphone. The smartphone, the ability to manipulate the smartphone as a user is the graphical user interface. The innards of the smartphone, the part that I don't see, the code or whatnot, is the part of the phone that is not the graphical user interface. This is something that you would get into great detail with when considering human-computer interfaces and how those operate. So let's jump right into it, shall we? So in this lecture, we're going to talk a lot about the design principles of graphical user interfaces. We're going to talk about how to create graphical user interfaces and how to process events in response to user interactions with GUI controls. We're also going to talk about the namespaces that contain the classes for GUI controls and event handling, and how to create and manipulate various controls. We're also going to go into detail about tooltips, which help the user understand when and where and how to manipulate the GUI, as well as how to process mouse and keyboard events using C#. Alright, so a graphical user interface allows a user to interact visually with the program. We just briefly went over that, but what that really means is that I'm able to, as I am doing with this PowerPoint slide, I'm able to interact with it in such a way that would allow me to manipulate the program and the various parts of it. I can draw, I can do whatever the program allows me to do. This is the graphical user interface for PowerPoint. There are graphical user interfaces for the operating system as well. The Windows directory interface. There are graphical user interfaces for your phone, as I made the argument there, that you can use your screen to manipulate the phone, and so on and so forth. So, consistent user interfaces enable a user to learn new apps more quickly because the apps have the same look and feel. Now, this is very important because having the same look and feel throughout your entire application allows for the user to feel more at home with new screens if they're added later on down the road, but it also grants the application a certain type of consistency that allows the user to use the application more intuitively. And here we go. This is a simple graphical user interface where there's a pop-up box that the Windows form creates, and there's a click me button that is presented to the user. This, of course, is within the graphical user interface that's presented by Visual Studio in your IDE. So, GUI controls are objects. We talked about objects a lot when it comes to, and we've created objects with our properties, but GUI controls are objects that can display information on the screen or enable users to interact with an app. And these are certain things that you can actually put in your GUI. Now, if you're thinking to yourself, well, I'm not necessarily sure I know what these things are, be not dismayed. You have touched at least 95% of the things that you see here. A label is pretty much text on the page. A text box is just that, a box that you can add text to. A button is just that, a button you can click. A checkbox is just that, a box you can check. A combo box is also called a drop-down list. Basically, it's a select statement, not a select statement. In HTML, we call it a select box, and it's got a little arrow caret here you can click on, and then it'll have a drop-down with the specific list of things that are in the drop-down. A list box is a list of items that you can make a selection by clicking one or more items. So a list box is more like a box that has items in it, and you can click each item, and then that item will be selected, and you can click another item and it'll be selected, and then you can go to the next page if you want to, or however that operation works. A panel is a container of things or controls. It really is just a section of your page. Panels are old school. They're not used nearly as much in modern development, but they come in handy when you're using C#. And numeric up-down enables the user to select a range of numeric input values, normally in a text box. It'll look something like this, and the user can click the up or down, and then it'll increment by 1 or decrement by 1 or whatever the case may be. So a form is a graphical element that appears on your computer's desktop. It can be a dialog, which is a modal, right? It pops up and saying, do you want to continue in the bigger page, right, of your application. A window, which is the full-fledged application window, or an MDI window. Don't get too hung up about what that means. Just understand that it's also a window. A component is an instance of a class that implements the iComponent interface, which defines the behaviors that components must implement, such as how the component is loaded. Alright, so let's stop for a second, because it went really fast, right? What in the world is an interface? And why are we talking about interfaces? So let's go a little deeper into this, shall we? I'm going to... Alright, good. So what's an interface? An interface is an object that is used to create a barrier between your class that is doing things and your program. So for instance, in this case, if I wanted to create an interface for Gradebook, I would do something along these lines. And I'm just going to go ahead and just go very quickly, but take my time at the same time. So new item, interface, which is still a class, mind you, and then I'll say iGradebook. Now we call it I in front of the gradebook, or I say I, not because it needs to be called I. I just lets me know that this is the interface for the class Gradebook. And normally you would put it in its own area, but in this case I don't really care. I want it to be accessible where it is. So iGradebook is now an interface. Now if I want to use iGradebook as an interface, I need to tell Gradebook class that it now has an interface. Alright, and I'm going to explain why this is important in a second, but let me implement it so you can see how it works. So I say Gradebook will inherit the interface iGradebook. Now, there's a subset of rules that we as developers live by in object-oriented programming in the modern era. It's called SOLID. That's the acronym SOLID. And the last letter in that acronym, D, stands for dependency inversion. And what dependency inversion does is it mandates that we use abstractions, not concretions. What does that mean? So when I go back to program, you can see that I instantiated the Gradebook class. This is called the concretion. I actually said I want an instance of the Gradebook class. Now, when you're developing, it might not look like that's a big deal. But when you have many classes, and there are applications that I write now where there's hundreds of classes, this can become a problem. And the reason why is because eventually this concretion will create a tertiary dependency, or a dependency that can be modified if I change the Gradebook code. If I change the Gradebook constructor, or the name of Gradebook, or anything, what that would do is it would break this dependency. It would break this line. This line would no longer work. Or the code might no longer work. So what we do is we create what's called a dependency inversion. We don't concretely call Gradebook. What we actually do is we say, okay, well, Gradebook contains methods that I want to use in the program. Methods, display message, and determine class average. So what I'll do in interface is I will say this interface contains abstractions from the Gradebook class. And I'll explain what that is in a second. So in this case, what I want to do is I want to look at the methods that I have here, except for the constructor, because that's not necessarily a method that I can use in an interface. I'll use this method, and I'll just say that exists there. And also, there's another method that exists there called determine average. Notice I'm not pulling the assessor. I don't care about the assessor. And for the most part, interfaces are all public. The reason why interfaces are public is because it doesn't really matter if they're private or not. The interface must be accessible to the entire solution file, because the interface will not contain any abstractions at all, or any concretions at all. It will not contain any implementations. So for instance, what's an implementation? If I look at public void, this entire method right here, the way it's written, the guts of the method, this part right here, the inside, that does something, that's the implementation. In the interface, I don't write the implementation because the interface is referencing this class. That's all it's doing. it doesn't care about what's inside the class. All it cares about is whether the class is void or not, and whether the class has parameters. So if I said void determine class average, boom. Now I have an interface. Now why is this interface really cool? Well, this interface is cool for two reasons. One, interfaces, or let me take a step back. In C#, classes cannot cannot support multiple inheritance. So what that means is I cannot use the same class and I cannot inherit the same class twice. Now that can become a problem, especially when I have a base class that I want to use over and over and over again in many different other classes. This gradebook class could be a base class that I use in, another class for printing gradebook grades or finding gradebook information. This might be my base class to get all my grades. So I would actually inherit from this class, but I can't inherit from this class. I can only inherit once. So in order to make it to where I can inherit from it multiple times and multiple different locations from multiple different methods and classes, I create an interface. This interface can be inherited anywhere at any given time, as many times as I want to inherit it. And I'm not going to prove that. I'm just going to go and do it once, and that's that. So here we have iGradebook. Now, if I wanted to use the interface, I wouldn't say gradebook my gradebook. What I would say is iGradebook new iGradebook. Now, notice that didn't work. The concretion was destroyed because now I'm not using the constructor from gradebook anymore. I'm using no constructor because interfaces don't necessarily support constructor. I mean, they do, but in this case, I'm not going to go there. So, new iGradebook. I'm still getting an error. Cannot create an instance of the abstract class iGradebook. That is true. That is very true, actually. So now, what I would say is, you see, use an unassigned local variable, my gradebook. I'm doing something wrong, and I don't remember what I'm doing right now. So, I don't want to have to show you guys dependency inversion because that would defeat the purpose of this. I would go too deep into the weeds, and I don't want to do that. Think. Because I can't instantiate this as a concretion anymore. Now that it's an abstraction, I can say, I just want to use iGradebook. Oh, right. Blah, blah, blah. This isn't going to work, but yeah, it's not going to work. It's a non-static field. And I'm actually doing something that's not, if you change it here, you have to change it in the actual base class. So here I'm changing it there too. And I'm not doing this the way that I would like to, but in this case, I'm going to do it this way anyway. Okay. I'm making them static so I can use them. An object reference is required for a non-static field property. Okay. I would have to do dependency injection, and I don't want to do that right now. Yep. Okay. I see what I have to do. And I'm not going to write that right now. But what you would do is you would write a service provider here and say all my interfaces are being promoted by the service provider. And then I would then I would use that service provider to push all the interface methods to the application. But in this case, I actually don't want to do that because that'll be too much. So I'm going to put the interface back. I'm going to disinherit. Well, it doesn't really matter if I inherit it or not. Save that. Save that, save that, and then put this back the way it was. There. And now it's back to normal. So just know that the interface allows you to use the methods from the class without invoking the actual methods within the class. What the interface will do the invoking. So think of the interface as your like a GUI for the programmer. It is the way that I press the button. The button is the interface, right? So in this case, iGradebook is the button, but you see how there's no code here. The code is actually contained within the code is actually contained within the actual class gradebook. I did just do this at work, but I'm not going to do it here because I don't feel that we have enough time in this class to do that. So, but I will probably make I'll go deeper into this in another video to show you how dependency inversion actually works. It's actually really cool and really awesome. So let's jump back. Yep, let's jump back. Sorry about that. So a control, such as a button or label, has graphical representation at runtime, meaning that the button and or label will display at runtime when the code is ran, as it does on an HTML form as well. And then we're going to see a Windows Form control and component C# toolbox, so you can add and drag things onto your form. After a while, you kind of don't do this anymore. You write your own, you write your own form controls. But this is a good way to get started to kind of see, but to see what is available to you. And here you go. Here's a toolbox, and it has all the different things that you can add to your GUI, so that the user can manipulate whatever parts of the GUI that they would like to. As you can see, there's a lot, and take that with a grain of salt. You can use whatever you want, whenever you want, but you don't necessarily have to if you don't want to. The active window is the frontmost and has the highlighted title bar. A window becomes the active window when the user clicks somewhere inside it. A form is a container for controls and components. So you have your panel that sits in a form. That's why it's called WPF, or Windows Forms. When you drag items from the toolbox onto the form, Visual Studio generates code that creates the object and sets its basic properties, and you will see that code when you look at the code behind. And this is one of the reasons why I don't drag my code over, because I feel that in dragging the code over, you get code that in dragging from the toolbox onto the form, you'll get things that you don't want. Like, remember I told you I don't like numbers in my variables, in my variable names? It'll do that. And I don't like that. And that's one of the many things that I would say that if you want your code to be clean, just after a while you understand what's in the toolbox and what you need, and you just write it out yourself. The IDE maintains the generated code in a separate file using partial classes. Don't get hung up on partial classes. All that means is that it is used to power the form. The form has a display code, D, and then it has the code behind, C, B, right? And the code behind will be run by a class, and this will more than likely be not a class. I'm not going to say HTML, but it will not be a class. Probably like a .wpf file or something along those lines. All right, and here you go. Here's some common properties that you'll find within forms. You have the accept button, the auto scroll, the cancel button. You have the form border style, the font, and the text. These are all normal properties that you'll find in majority of GUI interfaces and or web pages when you develop your user-facing code. And here's a little bit more. I'm not going to go over it. It's pretty self-explanatory if you want to read it. So GUIs are, for the most part, event-driven. This is true. When the user interacts with the GUI component, the event drives the program to perform a task. A method that performs a task in response to an event is called an event handler. So, if I put a button on a page, and someone clicks that button, if all I did was put the button on the page and someone clicks it, it will do nothing. The reason why is because I did not add an event handler to the button. I need something to listen for a specific action to occur. In this case, the event would be a button click. So I want the button to listen for a button click, and when it does, here's the button click, I want you to do some stuff after the button is clicked. That's what, in a nutshell, as an example, what an event handler does. Now you can have event handlers for key press, you can have event handlers for scroll over or mouse over, mouse off. You can have event handlers for a ton of things. The form in the app contains a button that displays a message box. So let's go ahead and create a Windows form application and do this, shall we? Alright, cool. So let's go ahead and close this. And let's close that. No, I didn't want to do that. I want the Solution Explorer for sure. But I did want to open a new file. New project. And let's go ahead and create a Windows Forms project. If I can. Console app, shared class library, web, WCF is not it. Did I not download it? That's not good. Let's check to see what I did wrong here. I mean, it should be Windows. I'm stuttering right now. Yeesh. Nah, it should be Windows Desktop, actually. I'm gonna go off on a limb and say this is it, but I want to make sure, so. Oh, I have to update. That's crap. Give me a sec. Oh, jeez. Alright, well, I'm not gonna wait for this. Or am I? No, I'm not gonna wait for this. I wonder if this will suffice. Is it going to ask me to close Visual Studio now? Because it actually finished doing what it needed to do. Well, let's just go over, and while that's going on, let's go over. Ooh, that wasn't good. Alright, cool. Let's go over what this is doing. So, we have a simple event example, and the partial class that they spoke of, which is inheriting the form class or the form interface, or well, in this case it's the form class. There's a constructor here that initializes the actual page, and then there's a button click function that on events args e, which is very important. This tells the page that there's an event behind the button, show that the button was clicked. And there you go. And I wanted to actually show you guys that. Oh, I don't have desktop development. Well then, modify. And while this is doing its magic, I should probably close Visual Studio. Yep, I know. I hear you. No, don't save that. Alright, continue. Retry. I do a lot of web development. Web API development, so I don't really need WPF, but in this case it'll come in handy to have. So, alright, sounds good. Let's continue on, and we'll come back to this when my Visual Studio updates. Hopefully it doesn't take too long. Alright, cool. So, to create an apps event handler, you need to double-click the button on the form. You don't necessarily have to do that. You can create it without double-clicking the button. You can write it yourself. This object sender events args e is very important for WPF because what it essentially does is it tells the program that when the button is clicked, I need you to execute a specific event. By convention, the IDE names the event handler method as object name _ event name, but you can name it whatever you really desire. You don't have to name it this specifically. Remember, the only thing that's important to this method is that it is void, because nothing will be returned. Well, okay, yes. That it is void, because nothing will really be returned from this button, or from this event. That it has a name that doesn't contain, reserved words, and that it contains these two parameters. The object sender, and event args with the variable name e. So, each event handler receives two parameters. The first, the object reference, typically sends sender, is a reference to the object that generated the event, meaning that the object for which we clicked, the button in this case, let's write that out. The button in which we clicked is the sender object that we're trying to load into that parameter. The second is a reference to the event args object, or an object of an event args derived class, which contains additional information about the event. It pretty much tells the program what it needs to do. So when the event listener is created, we don't have to define how it listens. We just need to define what it does after the event was executed. Event args itself will know what to do. Visual Studio places the auto-generated code in designer.cs file of the form. Open this file by expanding the node in the Solution Explorer window for the file you're currently working with, and double-clicking the file name that ends with designer.cs. And I'm actually going to do that in a couple of parsecs because it has finally loaded. It's finishing up right now. It's finishing up. So hopefully that does its thing, and then I can go back and kind of show you how that works. Since this code is created and maintained by Visual Studio, you generally don't need to look at it. You need to look at it. You need to get familiar with understanding the way the code looks, because you're not always going to get the opportunity to use WPF. In Windows forms and things, or in web forms and things of that nature, you will not get the opportunity to just fire and forget. You're going to need to really take a good hard look at what you're developing, or what the code is trying to give you. So let's go ahead and try this again. There we go. Okay, cool. Alright, so now if I go new project, I have the WPF app. Hey! Alright, so that works. I have a Windows Form app and a WPF app. I am interesting. Okay. We're just going to name this chapter 14. Or no, we'll name this GUI. Chapter 14. C#. And I will leave it where I normally leave it. And okay. I can't use sharp like an imbecile, so I'll just do that. Alright, so now let's head on back, and let's actually write the code. So straight off the bat, you can see that we have our window that pretty much tells us what we're looking at. We don't necessarily need okay, good. So this is the XAML is the graphical user interface, the part the user is going to interface with, and the main window XML is the or the CS behind the code behind is the class. This is a partial class because there's a lot that is integrated with it. So we're just going to do the main window for now, and let's go ahead and write that button in there, and let's make it work. And we're going to say click. I'm not going to write all that stuff in there. We're going to say object sender. Args E. Notice how it just resolved all by itself. It knows what to do. Message box dot show. We'll say hello world. And then what we're going to do is we're going to go back to the window, and we're going to add the button. So in this case, we'll just go to the toolbox, button. Yeah, go ahead. You can do it. It's thinking about it. Maybe my computer just took a big dookie. Come on. Please. There we go. Alright. And as you can see, it added the button to the grid. I can move the button if I would like to, and I would like to. It's not going to let me. There we go. Alright. I'm going to name the button. So the button right now has no name. So let's go ahead and name it, because button doesn't fit right here. We're gonna name it modal click test. Now, what I just did there is very important. And in Visual Studio, if you space out of anything, what it'll do is it'll give you all the properties of this specific object that you're modifying. In this case, I don't remember how to add the program, or not the program, but how to add the application, right? So I need to, I'm just gonna scroll really fast, if I remember correctly. I think it's event, but I think I passed it already. On click, actually, now that I remember. Or not. Mouse wheel up, mouse wheel down, mouse wheel move. I see all these actions, but there it is. Click. I don't want a new event handler. I already have an event handler. So I actually already have an event handler that I want to use. So I'm going to name this one click. I'm surprised that click's not showing up. Button base.click. Yep, that should work. So let's go ahead and let's run that and let's see what we get. And then I'll kind of go over what we just did. So here we are, modal click test. If I click it, hello world, it executed. So it did exactly what I wanted it to do. Wonderful. And this is the Windows, this is the WPF, the Windows forms. So what happened? Well, XAML acts like HTML, and it displays the actual application for you. So in the XAML, we redrug the button over, and we put it inside the application. Now we can use a graph. We can use this designer here to kind of manipulate and see what we're doing, and it makes life a lot easier. But there's a grid here that we're putting all of our things into. Then what we did was, for this specific window, we have a class that is the partial class for the window. It's the code behind. And what it essentially does is it inherits the window object, or the window class. And in the main window partial class, what we're doing is we're giving it commands on what it needs to do at specific intervals. In this case, because it is a void function, nothing will be returned from this function. The entire purpose of this function is to execute an event receiver when the button is clicked. As you saw, I said click, I want you to run the click function, right? But what if I didn't say click? What if I said mouse enter? Would that work? And how would it work? So let's start that. Here we go. We have the program. Now, I changed my event handler, or my event listener from click to mouse over. So what would happen if I do the mouse over? I got the modal. There's many different events that you can do, and you can add to buttons and pictures and whatnot in your code to make it do certain things. Click and scroll are not the only two actions that are available. And if you want to see what the actions are, like I just did, I moved right next to the end of this call here, into this property, and I spaced over. Anything that has the lightning bolt next to it is an event. So all of these things you're doing, a context menu closing, context menu opening, data context changed, drag enter, drag leave, drag over, drop, all of these are events. You can add these events to the button. Now, some of them may not work, but you can add as many events to this button as you would like to, and it will do exactly what you want it to do based on whatever function in the code behind. In this case, the main window.xaml.cs is directly tied to this page, will execute. All right. Let's do it. So, now that we went over that, so since this code is created and maintained by Visual Studio, you don't necessarily need to look at it. I would suggest you look at it. It's very important to look at. Now, dispose means exactly what you see here. It disposes of the object that you were using. And that's very important when you want to do memory buffering and memory, when you want to be cognizant of the amount of memory that you're consuming. And here we go. Here's an example of the code behind for simple event example form. They initialized a component and they added a new button to the form, and then they said, I want you to suspend the layout. And then this.click button location is adding all the properties to the button based on the initialized component, which you saw in the main window when we said initialize component. And then, give me a sec. And then we added more properties to different parts of the page. So auto scale dimensions, drawing, and all this stuff. This is how you would actually generate the page with nothing but C#. This is all generated by the page itself, actually. If I showed you, let me see if I have the right thing up. I do. So this is the actual initialized component that they're looking at on the left or in the PowerPoint. This is the initialized component for the program that we just wrote. And you can see how it's adding the button at a specific spot in the page. It has a case statement. Well, fancy that. This is all generated by the code when we use the designer to create, or when we use this XAML designer to create the WPF. All right. The partial modifier allows the form's class to be split among multiple files. Figure 14.7 declares the click button that we created in design mode. It's declared as an instance variable of class simple event example form. The property values correspond to the values set in the properties window for each control. Method initialized component is called when the form is created. This is very important. The initialized component is called where? In the constructor. Therefore, that when the form is created, the initialized component is also created or instantiated. The code generated by building a GUI in design mode is not meant to be modified directly, which is why this code is placed in a separate file. Modifying this code can prevent the GUI from being displayed correctly in design mode and might cause an app to function incorrectly. In design mode, modify control properties only through the properties window. And they're right. When you're in design mode, as you just saw I was doing, don't modify the code behind I just showed you with the initialized component code. That initialized component code is created by the designer. So you're better off just using the XAML designer and not modifying the code that I just showed you. And when I say the code that I just showed you, I mean this. This is that initialized component method that you don't want to modify. So what you want to do, what you should do is go to the XAML, modify it here, and then modify the class that is the code behind. All right. So delegates. Delegates are event handlers are connected to a control's events via special objects called delegates. A delegate type declaration specifies the signature of a method. In event handling, the signature specifies the return type and arguments for an event handler. A delegate of type event handler can hold references to methods that return void and receive two parameters, one of type object and one of type event args. This is a lot to take in. Just understand that delegates are what event handlers use to ensure that events are executed appropriately. So, a button calls its event handler delegate in response to a click. The delegate's job is to invoke the appropriate method. This code is added by Visual Studio when you double-click the button to control in design mode. New system.eventhandler this.click button _ click. Adding more delegates to an event is called multicast delegates. Controls can generate many different events. Clicking the events icon, the lightning bolt icon in the properties window displays all the events for a selected control. Now remember what I showed you earlier. I showed you that the code itself can be, you can see the events by looking here inside the XAML code, but you can also click the events icon. Where's the events icon? In the properties window. So if I don't have the properties window open, actually. I don't have I do not have the properties window open for this context. It would show up right here, and then there you would see all the events. And I'm trying to see if I can pull it up. I don't see it. I think I'm just missing something very simple. I honestly don't like the properties view because it's not very easy to use. That's not what I wanted to do. Goodbye. Well, this is how you can see pretty much everything right there. So, all right. Oh, well, I still don't... Well, hold on a second. I think I know where that is, actually. No, because the button object is not being extended to the Solution Explorer for some reason. Why is it not being extended to the Solution Explorer? All right, I'm gonna stop fiddling with it. Wait, hold on a second. Nope, that's the properties of the actual application. That was not what I wanted. Huh. Well, like I said, I don't use the properties window all that. There we go. All right. And then if I want to see all the events, so what I did was I went to View, Properties window, and then if I wanted to see all the events for the button, it has no name because we didn't name it, I can say you click the events, and here are all the events that are available. Obviously, I think we've already done this. Oh, for mouse click. Let's go to mouse click. There it goes. Mouse click has an event. If I wanted to change that, I can say that, and then there you go. There's another click method that was opened, and in the button, I should see a click function, and there you go. So it'll automatically add it, not only to the button, but also to the code behind. But I like to do it manually because I know that it was done. Well, I like to do it manually. And as you saw when I erased that click equals click, it also erased in the properties menu. All right. Read the Visual Studio documentation and learn about the different events raised by each control. Or you can just go here where we were here and just modify it yourself and see what they all do. To do this, blah, blah, blah. If you want to do that, go ahead and do it. If you want to just get in there and just play with it, that's basically the best way to do it, to get in there and play with it and kind of see what it does. Just get in there and play with it, put in different things and see what different things actually do. And here's the button class hierarchy. This is very important. Get used to looking at these developer references because they can give you a lot of information on what things do and what things don't do. So you don't beat your head against the wall trying to figure things out. It's already been figured out for you. All you have to do is put it together like Lego pieces. Excuse me. And here we go. Click control.click tells you how the click function works, and that is an event handler. And if you keep scrolling down, it will give you an example. The example code is really what you want to see, because it tells you how you can implement it yourself. Controls derive from class control. And here are some properties of the control class. You have back color, which is the background color. You have the background image. You have whether that property or control is enabled. You have focused, meaning whether that control has focus at runtime. The font, the for color, which is the color of the text property. Tab index, which tells you when the tab key is pressed, and the tab order of control, and tab stop. Text, visible, hide, select, show. All of these are pretty much self-explanatory. These two slides can be very important if you would like to remember what these control properties and methods actually do for you, or if they are available to you. So anchoring causes controls to remain at a fixed distance from the sides of the container. Anchor a control to the right and bottom sides by setting the anchor property, meaning that it won't move based on whether or not the form's application is resized. And there you go. Defines edges of the container to which a certain control is bound. So if you execute the app and enlarge the form, and for in this case, let's do this. So let's go ahead and anchor this to the left. I want to there we go, anchor. What did that do? Anchor. I think I just anchored it. We're about to find out though. Start. Alright, so it's on the bottom right hand side, correct? If I do this, it didn't anchor it. Oh, it did anchor it. Alright, cool. It didn't move with the application, and it still has the mouse over the mouse enter, which can be rather annoying. But it anchored itself to this location, I think. I'm unsure if that's the way that was supposed to work. I think that let me see something. Okay. I just want to test it. There we go. It's anchored now. Oh, the other one was not anchored. So now it's anchored. It's not moving from the bottom right side of the application. Is staying there, which is exactly what you want if the window is resized. This is called anchoring, what I just did. These two links are anchored 32 pixels and 27 pixels from the... Let's just go ahead and make that. There. Now it's equidistant from the right and the bottom. And as this moves back and forth, it'll remain in this location. These are anchors. These are not anchors. These are, absolute positioning, I believe. All right. And these are anchors that you can test if you would like. So docking attaches a control to a container such that the control stretches across an entire side or fills an entire area, like a menu. Docking allows a control to span an entire side of its parent container or to fill the entire container. The form's padding property specifies the distance between the docked controls and the edges. So there's padding and there's margins. Margins control how much space is between the outside of the application or the outside of an object and whatever is in the container which it is within. Padding controls the inside of the document and the container that it's within. So when you do this docking, it'll use up the entirety of the application space based on how you dock it. This is docked horizontally. You can also dock things vertically. And here's the anchor, dock, You have padding, location, size, minimum, maximum. Visual Studio provides tools that help you with GUI layout. When dragging a control across a form, blue lines, known as snap lines, as you've seen, help you position the control. Visual Studio also provides the Format menu, which contains several options for modifying your GUI's layout. And as you saw, I was just dragging and dropping and moving things around, and the same thing can be done here. The snap lines allow you to see where your objects are and to move them accordingly. Label displays text that the user cannot directly modify. Labels are more like printed text. As you saw on the button, there's Moto Click Test here, and Moto Click Test. Inside Moto Click Test, the writing in Moto Click Test is a label in the button. You can also write directly into the page using a label. You would have to go into Toolbox, Label, and then drag it onto the WPF as I just did. Wait for your computer to not lose its mind, and then you can write into it. Here's a label, and then I can write into the label. So now I can say I should be able to something that works. Yes, I'm aware. Oh, there it is. Right here. There you go. Content contains the direct text for the label. And there you go. If this is ran, the label would be printed to the form, as you see here, but I can't modify it at all. It is there, and it cannot be changed or anything of that nature. So, let's jump back. We can text align, we can change the font, and we can change the actual text of the label. A text box is an area in which either text can be displayed by a program or the user can type text via the keyboard. If you set the property use password char to true, the text box becomes a password text box, and you can encrypt the password if you do that. These are the methods these are the properties that you can put into the text box. One property that you might find very interesting is read only, which disallows anybody to write into the text box once it is created. You can also do text changed as an event in the text box to do specific things that you would like to do, like calculations and whatnot, when someone writes into the text box, or to try to auto finish the word that they're typing. A button is a control that the user clicks to trigger a specific action or to select an option in a program. A program can use several types of buttons, but all the button classes derive from class button base. And here are some common events of class button, but we've gone over a lot of these already. So here's some events. Click. I didn't show you mouse over like we have now, but there's a lot. Uses a text box, a button, and a label. And here we go. So here's the label text box button test form. The component was initialized, and then the password.click is the actual button here, and it says that it wants the input password text box text to display in the label here. Well, this is a text box too, but all right. So, group boxes and panels arrange related controls on a GUI. All of the controls in a group box or panel move together when the group box or panel is moved. Now, this is really nice when you put together a specific subset of things you want to be the same. Like you have a page and you want the person to input their information in that page, address, phone number, or a panel. And then when you decide, okay, well, I actually don't want this panel here. I want to move it to a different side of the page, or I want to move it to a different window altogether. You can just move the panel or the group box, and everything that's in it, text box, labels, buttons, it'll move to wherever you move that panel to. The primary difference is that group boxes can display a caption and do not include scroll bars, where panels can include scroll bars and do not include a caption. The problem with panels is that they can create scroll bars within the panel. So you'll have the window that has a scroll bar, and then the panel will have a scroll bar. I think you guys have seen that before. It is not very visually stimulating. Panels and group boxes can contain other panels and group boxes for more complex layouts. And here we go. Those are the properties for group boxes, and these are the properties for panels. You can organize a GUI by anchoring and docking controls inside a group box or panel. The group box or panel then can be anchored or docked inside a form. This divides controls into functional groups that can be arranged easily. So to create a group box or panel, drag its icon from the toolbox onto the form, the same way that we did the button. Then drag new controls from the toolbox directly into the group box or panel. To enable the scroll bars, set the panel auto scroll property to true. So in this case, let's go ahead and just jump over here, and let's put a panel in here. So and I think static panel is the what we need to do. And I'm going to wait for my computer to pull its finger out. While we're doing that, check my phone. I actually have a very good computer. I don't know why it's taking us a while to do these things. But here we go. Here's the panel, and then I can just drag it over my label test, put my button into the panel, press Alt to place it in the stack panel. Don't mind if I do. And there we go. It's in the panel. It is locked in. I don't want that. Don't be locked in, please. Don't lock yourself in. Well, whatever. It's in the panel. And there you go. If I wanted to move this panel around, guess what? The button is now in the panel. Put this inside the panel as well. And now, oh, I did not want to do that. But I'll leave it. That's kind of cool. I really want the button. Alright, there we go. And now, if I start this, there you go. You can't see the panel, but you can see the button and the label. They both exist in the panel as we know it here. I'm trying to move the button, but it's not really working. But oh well. Alright, so let's go back. And there we go. They placed a bunch of buttons in there, and then they tested the scroll bars. I'm not going to turn the scroll bar on, but you can. As a matter of fact, I can show you what that looks like. If I come over here and I double click or right click and I say well, there's always I can do it. I can always do it here. So stack panel, and then I can say scroll bar equals true. Is not recognized or is not accessible. Why is that? Oh. Oh. Interesting. They changed that. And I guess it just created that function, did it not? It did. I wonder if that's all I had to do. That's interesting. Let's run that and see what happens. Huh. And then if I did this? No. Nah, that didn't work. Alright, well, I'll figure it out. But that's actually not what I want. I think it's auto scroll. Give me 1 second. Yeah, it's auto scroll. But I didn't see auto scroll. Interesting. Maybe it's a specific panel that I picked that doesn't do it the way that I remember, but that's fine. Alright, let's go back and continue. Use panels with scroll bars to avoid cluttering a GUI and to reduce the GUI size. The panel in figure 14.24 uses a group box and a panel to arrange buttons. And here we go. We have the initialize component here that initializes the form. We have a button that has a click event associated with it, and basically what it does is it takes high pressed and it adds it to the message label.txt, or the message label that's in the window. There's another button that says goodbye, does the same thing. There's a button that says left button, and then it prints far left pressed to the message label, and there's a right button click that says far right pressed to the button label. And there we go. This is what it would look like. When high is pressed, high pressed. When by is, or far left is pressed, far left pressed. Far right pressed. A checkbox is a small square that either is blank or contains a check mark. You can also configure a checkbox to toggle between 3 states by setting its 3-state property to true. Any number of checkboxes can be selected at any time. And, for the most part, checkboxes look like this. You've seen them before. And there's also checked changed as an event that can be initialized. And then new things can be added. Not new things, but actions can be added or whatnot. In this case, the font of the label is being modified when the checkbox is checked. To change the font style on a label, you must set its font property to a new font object. The font constructor we used takes the current font and the new style as arguments. Combining font styles with bitwise operators, operators that perform manipulation on bits of information. We needed to set the font style so that the text appears in bold if it was not in bold originally, and vice versa. The logical exclusive OR operator makes toggling the text style simple. So radio buttons are checkboxes, but only one can be selected. Radio buttons normally appear as a group, in which only one radio button, like I said, can be selected. All radio buttons added to a container become part of the same group. So you'll have a group of radio buttons, and when one button in that group is selected, the rest of the buttons are not selected. But if you select another button in that same group, the button that you selected the first time is deselected or unselected. Use radio buttons when the user should choose only one option in a group. Use checkboxes when the user should be able to choose multiple options in a group. Checked changed is also an event in radio button. Forms, group boxes, and panels can act as logical groups for radio buttons. The radio buttons within each group are mutually exclusive to each other, but not to radio buttons in different logical groups. So if I have buttons here, and I have buttons in this group, these buttons will not affect these buttons. If one button is checked here, these other ones are false by proxy. If I try to check another one, this one would get unselected. But this one, the one that I just checked, has nothing to do with the other group of radio buttons. And as such, I can check something else over here and it not affect these radio buttons because it's in a different logical group. And here we go. Here's radio buttons test form. You can see that there were two variables that were instantiated or initialized. The form was loaded with the initialized component in the constructor. And then there's an if-else-if branch here. Now, when the button is checked, if the sender says OK radio button, or if the button is display the OK button, the button type will be displayed. If cancel was what was sent, display both OK and cancel. If the abort, retry, ignore radio button was selected, display that, and so on and so forth. The same with the icon check changed. It'll do the same thing. It asks to see what was checked, and then it says display that specific icon in the icon type variable. And then the display button click does the work. And here we go. Here are all the radio buttons. And if a specific radio button is checked and the display button is clicked, you'll get a specific message box that contains the buttons that you asked for. And the exclamation icon was displayed as well. And here's if you clicked OK, cancel, OK, abort, retry, ignore, yes, no, cancel, yes, no, type, retry, cancel. These are all pre-made modals with pre-made buttons in them that you're calling based on what is being checked in the radio box. A picture box displays an image and normally has a specific event associated with it. A picture box is just a really nice way of saying a button with an image associated with it, or an image button. I'm not going to go over the code here, but here we go. Using the picture box to display images, you can say next image and it will change the image for you. Embedding the images in the app prevents problems of using several separate types, separate files. To add a resource, you just click the properties of Solution Explorer and add. So, there you go. Very simple. It looks like this. So I would come in here. This is the solution. This is the program. I would say right click, add. In this case, add item, bitmap file, and then I would just add it. Or actually, in this case, I wouldn't add new item. I would add existing item. Sorry, and then I would find that existing item, and I would add it to the project. A project's resources are stored in its resources class. Its resource manager object allows interacting with the resource programmatically. To access an image, use the method getObject, which takes as an argument the resource name as it appears in the Resources tab. The Resources class also provides direct access with expressions of the form, so resources dot and the resource name. Recall that tooltips are the helpful text that appears when the mouse hovers over an item in a GUI. The amount of time in milliseconds, or here's tooltips. You can have the pop delay, you can have initial delay, reshow delay. The draw event will raise the tooltip when you have a specific event. This is the event that is executed when the tooltip you want is to be promoted.
All right, let's jump back in. So a tooltip component appears in the component tray. A tooltip on the property for each tooltip component appears in the properties window for the form's other controls. And here we go. Tooltip. I think you've seen these before. They basically just tell you, hey, this is what this does, or this is what this is. To set a tooltip next to the labels for first label and second label, what you need to do is go into Visual Studio. And let me see if I can do just that. And let me see really quickly Yeah, that's what I thought. So tooltip is an event. And let me. Uh, Interesting. There we go. What was going on there? All right, so like I said, tooltip is an event. If I scroll over label and I say tooltip, or it's a property, I'm sorry, and then I can say first label, save, and then I start this program. If I scroll this over here, I have a tooltip. There you go. It's really easy. A lot of the properties and events are already available to you within your program. All you really need to do is make sure you see them and then use them appropriately. You see how the tooltip only lasts for a certain amount of time and then goes away? You can actually modify that in your code, in my label line here. I can add how long I want the tooltip to last for and whatnot. And I can also do tooltips for the button as well. Interesting. There we go. Why was it doing that? Is that not working now? I guess it is. Okay. OBS was acting very weird. Alright. Weird. Alright, so back to it. We set the tooltip for first label, just did that. And you can set the tooltip for the second label, not going to do that. And you can demonstrate the way the tooltips are shown in the component tray. Once again, that's something you can see in the Solution Explorer, but it's not something I'm going to show you at the moment. So figure the next thing the next slide will demonstrate how you can set the tooltip, but I just showed you how to set the tooltip. You can set the tooltip in the properties, or you can set the tooltip in the actual line of code. I suggest you do it in the line of code. I know that it tells you not to, but the more code you write, the better you'll be at understanding the way it looks and how it operates. The less code you write, the less you'll understand how it operates. So like I said, if I do, come over here to the code, and I just space, you saw what I did, I'll do it again. I go to, it doesn't matter which one of these names you go to, or which one of these properties you are next to. Just get right next to it, space. Your IntelliSense should show up, and it'll show you all the things that you need, or all the things that you can do within that specific line. So in this label, I can do these things. Button has its own properties and events and collections that I can load, that I can use, whatever the case may be. Each one of these tools in the toolbox has a specific subset of events and that we've spoken about, properties and whatnot, that you can modify. And it's a truckload. You can go to properties and do it, but that defeats the purpose of actually learning how to develop. This is really where you want to do it. So get used to modifying the code. Get used to being knee deep in the ones and zeros, because then it'll make more sense later on down the road, and make it easier to learn what you're doing, and so on and so forth. So, enough rambling on about that. Restricting a user's input choices to a specific range of numeric values can be done with the numeric up-down control. A user can type numeric values into this control or click up or down arrows. You can use the numeric up-down control to control specific events and properties. They can control, well, not control, but you can use it to do calculations on each button click and whatnot. And it looks something like this. I'm not going to go over the properties and events. I'm not necessarily too much a fan of the numeric up-down, because if you want to do large changes in numerical value, you can't. Well, you can, but it's cumbersome. So we set the minimum value to 1, maximum to 10. They're showing us how they did the numeric up-down. They also set the numeric up-down's text box to read only, so that you can only use numeric up-down clickers, numeric up-down arrows. Like I said, I'm not a fan of numeric up-down, but it's good to know. Here's the actual code, so we'll go over it really quickly. You have a partial class that is powering the interest calculator form, and it's inheriting the form class. In the constructor, we initialize the actual form, and then we have a button or a click event handler that has a couple, well, not a couple, but a few initialized variables. In this situation, it looks like we're trying to calculate the dividends that would be returned from a specific investment. And then it has a for loop that counts or it does a calculation based on what year you're in, and then it displays that output in the text box. This is just retrieving the user input from the text boxes that are available to us. And here we go. You add the principal, you add the interest rate, you add the years, which has a numeric up down, and then this is probably read only, if I'm not mistaken. They didn't show us the code for the GUI, it just showed us the code for the class. Then you hit calculate, and then it puts the information for this calculation inside of this text box here. So mouse events are generated. We talked about mouse events. We used a mouse event actually for the button. We did a mouse over. So we did kind of go over this already. And like I said, like we used mouse enter, I believe. Mouse hover also does exactly what mouse enter does, but it executes on hover and continues to execute while you're hovering. There's also more mouse events. So mouse wheel, mouse up, mouse move, mouse down. These are all mouse movements that are inherent to the mouse itself. And the properties inherent are also here that allow you to, when the mouse reaches this X value and this Y value, do this event. And here we are looking at a WPF application that lets you draw on the form. So once again, we have a painter form class that's being inherited from the form class. It has a Boolean value of should paint, which is initialized to false. It then initializes the component within the constructor painter form, and then it gets down to the business. So here we go, private void painter form mouse down. So when you're dragging the mouse down, it should paint. When you're dragging the mouse up, it should not paint. When the mouse move, if should paint is true, okay, that's what this is saying. If should paint is true, then use the graphics class and start creating graphics. Use a solid brush, paint as a blue violet, and hot to it. And it looks something like that. Mouse up means when you button click, that is mouse down. When you unbutton click, that is mouse up. So while you're clicking, while your button is still clicked down, draw. When the button is clicked up, do not draw. So recall from chapter 13 that we did not go over, that the using statement automatically calls dispose. This is something I talked about. I don't think that we talked about it in chapter 13, but the using statement is a special statement in C# that tells the program to dispose of objects after you are finished. So for instance, let's say I have a using SQL connection. Let's say I need to connect to SQL, right? And I'm using ADO.NET. And I have using SQL connection string. I have my connection string, and then I'm finished. Well, if we never close this SQL connection, what will happen is it'll continue to take up space in the RAM and could possibly take up more space as it tries to maintain that connection. So what we want the program to do after we're finished with that connection is get rid of it. Now, normally in the past, you had to say SQL connection, or in this case, my variable would have been connection dot dispose, and then it would have gotten rid of it, or so we thought. Well, sometimes programmers, developers, aspiring individuals we are, forget to do this. So what using does is it does it for us automatically. At the end of the bracket in using, this will go away. Now I know this is kind of higgledy-piggledy, but let's jump over to the actual program. And I'll show you exactly what I'm talking about. So in this case, we'll get rid of that. Let's say the button would reach back to a couple of values, right? Let's say the button reaches back to SQL using ADO.NET. Now, in today's day and age, we don't use ADO.NET. We use Entity Framework. But there are situations where ADO.NET makes sense. Like, for instance, when I was, and I know I'm speaking gibberish right now, but bear with me. When I was working this week, I realized that there are certain inherent flaws in Entity Framework that I can't work around. For instance, if I wanted multiple result sets from SQL, so in SQL I said select, 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 and the results came back with multiple result sets, multiple tables came back, or multiple select statements came back. In Entity Framework 7, you can't consume multiple result sets as of right now. I'm sure they're trying to change that. So what you have to do is you have to use ADO.NET. What's ADO.NET? Well, ADO.NET is C# and .NET Core's version of manipulating SQL. And it looks something like this. So I would say SQL connection. Oh, I would have to import SQL connection actually, or the using statement. So it would resolve. There we go. So SQL connection con equals new SQL connection. In this case, I don't have a SQL connection, so I'll say I just won't even care about the connection string. Normally, what you would do is you put a connection string in here, but I'm not going to do that. I'm writing it the old school way, and then I'm going to show you how using works. So con.open. So I open the connection, and then I want to do some stuff. So I'll say SQL command com equals new SQL command, and then SQL data reader. I'm not going to execute any commands right now. Reader equals, and I guess I can say con here, and then SQL data reader, or I'm sorry, SQL data equals not new SQL data reader, equals, I guess it is new SQL data reader, isn't it? Yep. And then command, oops. Okay. And then I can do some stuff, right? So while reader dot has rows, do something. All right. So this is basically, and I know it's going to give me errors. I understand that because I didn't give it a connection string back to SQL, and the SQL data reader doesn't really know what it's reading from, but I'm not going to figure that one out right now. I'm just going to show you how this would work I'm not going to even run it. So in this case, it would open a SQL connection to SQL. It would then execute a SQL command based on the connection string. And then after that, it would execute SQL data reader and read from SQL. After it does that, I would use the reader class or the reader variable, as long as it has rows, and I would read from the table that I want to read from. Well, excuse me. Well, there's a problem here. The SQL connection will remain open and will never close. Even if I say con.close, that SQL connection object will still remain in memory. So what I actually need to do is I need to dispose of the object. So in the old days, we'd say dispose, and what that would do is it would trash. It's called garbage collection. It would just throw away whatever we were trying to get rid of. In this case, the entire SQL connection. But this is not always the case. Developers don't always use dispose, and sometimes dispose in that form doesn't really work. So instead of doing that, and this is very important, which is why I'm taking the time to explain it to you, what usings do is it basically is a while loop that says while we're using this SQL connection, I want it to stay open, or I want it to stay available, not open. And when this is over with at this bracket at the end of the using, it'll dispose. So that .dispose that I wrote actually disposes here at the end of the using. Now you can do multiple usings. So in this case, I would do another using for the SQL command because I also want to get rid of the SQL command object after it is finished doing its magic. So There. Now, the using object or the SQL connection will be disposed of at this bracket, and the SQL command object will be disposed of at that bracket. And now I don't have to have a bunch of disposes that I don't know if they do what they're supposed to do or whatever the case may be all over the place. I can just say using. This is what a using statement is, in a nutshell. Don't really get into the don't get too wrapped up about what using actually means and where it came from and why. That's not important. Just understand that it disposes of the object that is within its parameters, and by doing that, it keeps garbage collection in your program. It keeps garbage collection in your program very clean. So that's using it in a nutshell. Maybe we'll go over it. I am unsure, but for now, I just wanted to explain that to you so it made sense. Now, back to the program. So, this is important because graphics objects are a limited resource, just like SQL connection strings are limited resources. Calling disposal on graphics objects ensures that the resources are returned to the system for use. What does it mean by resource? RAM and CPU cycles. If you want your CPU to sound like mine does right now, going a million miles a minute and the fan just blurring in your ear and threatening you with the blue screen of death, then yes, by all means, don't use dispose and just absorb all the resources that your PC has and see how large the flames will get out of your box. I'm being facetious, but seriously, disposing of your objects is very important, especially in production environments, because you can bring down servers by not taking into consideration the amount of resources your program is actually using. And in certain situations, your program might not be the only program that's being used on that box. So the key press event occurs when the user presses a key that represents an ASCII2 character. The key press event does not indicate whether modifier keys were pressed. If this information is important, the key up or key down events can be used. Key up and key down are very important. So you had the numeric up down that controlled what variables or what numbers were added, or what characters were added to the text box. Well, I told you I really didn't like that because it's very restrictive and it doesn't really give the user that the ability to modify, manipulate using the key buttons, because you would have to make this read-only for them to use the numeric up-down. Well, to modify this text box to do what you want to do without using the numeric up-down, what I would do is I would actually tell the program I only want, let's say this is a numeric text box, I only want specific keys to be pressed. And every button that is on my keyboard is represented by a specific ASCII2 character. So I can say I want to, when the key up or when the key down event is executed, I only want certain ASCII2 characters. And if the user executes the wrong ASCII2 character, let's say they typed a letter in the box when there was supposed to be a number, deny that the letter be entered, so then the letter will never be entered, and then notify the user that only numbers can be added to this text box. And here we go. Key down is a very important event. I use it a lot. Key press is also a nice event. It's raised after the key down and before the key up. So key press is the holding of the key. Key down is when you press the key down. Key up is when you release the key. So key data, key value. And here we go. Let's talk about it. So we have the partial class key demo that's being inherited from the form class. We then have the constructor key demo being initialized, so the form's initialized. And then we have the key demo key press method. And basically what we're doing is we're saying, hey, look, we want the event, so whatever key was pressed, I want that character to be added to the text box, or I'm sorry, to the label that I have in my form. And then on key down, I want to see if there are any other keys that were pressed. So in this case, we have ternary operators here. E.alt, meaning if was the alt key selected? No. Yes. If it's true, say yes. If it's false, say no. And then line break. And then next, was a shift pressed? If true, say yes. If false, say no. Line break. Was control pressed? If true, say yes. If false, say no. Line break. And then add the key code with the line break.
add the key data with the line break, add the key value, and that's it. On key up, erase everything. Or erase the chart label and the key label info text, and get ready for the next key. And there we go. And that's the way it works. Was the shift key pressed? Yes, it was, in order to get the money tab. To cause a control to react when a particular key is pressed, such as enter, handle a key event and test for the pressed key. To cause a button to be clicked when the key enter is pressed on a form, set the form's accept button property. And that's it. That was a long one, and there's a part 2, but that's it. I want to say that this is really the nuts and bolts of WPF. This is what makes WPF powerful. You will find that most organizations don't necessarily use WPF because WPF is only accessible to the box that it's on, right? The box that it's on. Whereas with a web application, it's on web servers that can be accessed basically by remote sites and whatever. So this is optimal. This is not optimal, but WPF gets you started in understanding the way that web applications work. So with that being said, I hope this was informational. I hope this helped you out. And if you need anything, just reach out. I'll be here. And good luck. Ciao.